Greetings and salutations. I'm Marv Candleman. You've seen me on such fine quality, epic chemistry educational chemistry videos such as Lost Amidst a Bunch of Chemicals, Part 1, and Lost Yet Again in Amidst the Chemicals, Part 2. Okay, where we're going to look at in this video, we're looking at naming covalent, covalent compounds. Okay, now the question comes down to, up to this point, you have been naming things that were ionic compounds, particularly binary ionic compounds like sodium chloride, potassium chloride, silver chloride, things like that. Now we're in a different realm, because that was a pretty straightforward thing. You could look at ammonium nitrate and potassium nitrate, and that's it. But what's the difference? Why would there be a difference between naming covalent compounds? What is a covalent compound, you might ask? And how do we know if one of these formulas here is a covalent compound or not? Okay, let's start with this. When naming covalent compounds, it's a little bit different because we tend to use numbers to identify how many of the first and or second part that we have, unlike binary, ionic compounds like sodium chloride or potassium nitrate or calcium benzoate. We don't talk about how many we have of benzoate in calcium benzoate. We just say calcium benzoate and that's it. But in covalent, that's a little bit different. So let's go with this. But how do we know if something is covalent? Well, let's take a look at SEF6 here. All right. Now, it is covalent, but how would I know? SEF6. If you look on the periodic chart, we know that our fluorine is up here and our Se is over here. We have to go back a couple of chapters to something called electronegativity. Yeah, we gotta go back to that. Remember, the idea behind electronegativity is how much the atom wants to attract shared electrons to itself. There are some atoms that they really want electrons very badly, like fluorine. In fact, it's got the highest electronegativity number. Hydrogen is pretty respectable too. So when you put hydrogen and fluorine together, yeah, it is a covalent bond that's there because electrons are being shared. It's a polar covalent bond, but it doesn't get the covalent naming treatment because it's an acid. But we're not going to worry about that. Now, when we look at something like sodium fluoride, okay, I want to point out for sodium fluoride, they're on opposite ends of the periodic table, which makes it ionic, so we don't have to worry about it. But look where selenium is here. Here's selenium. Here's fluorine. Look how close they are together. The closer that the two elements are on the periodic table, the more likely it's going to be covalent as a compound. And remember, the idea behind covalent is where the electrons are shared between the atoms. Now, that may be equal sharing, it may be unequal sharing, doesn't matter. Electrons are being shared, whereas in ionic, one atom literally has its electron transferred to the other. So that's where you see the difference. But we're looking at covalent. So I know it's covalent. I got selenium and fluorine. Okay, how do I name it? Well, the first part of it's going to be very straightforward. It is in fact going to be selenium. Okay, and then I've got 6 fluorides. Now remember, they did get their hands on an electron. So we don't say selenium fluorine 6, but we do put a prefix in front to tell us that we have 6 fluorines. How do we know the prefixes? Okay, mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. So let's go with that. So selenium, hexa, fluoride. Did I identify all the parts? Well, I identified the selenium right here, that's the Se. The fluoride, yes, I identified we have fluoride in there, but I had to address that there's 6 of them. So we have hexa, meaning 6, selenium hexafluoride. So that's our first one that we have, ladies and gentlemen. So let's go with this one here, TeO3, tellurium. But let's check, where is Te? It's right here. Here's tellurium, here's our oxygen. They're fairly close to each other. Remember, in ionic, they gotta be far apart from each other. But when it's covalent, they're really close. So that's gonna be a huge clue as to what that's going to look like. So tellurium oxide, let's see. So we know that we're gonna have tellurium. Now we're going to have an oxide in there, but we've got 3 of them, right? So that's going to be trioxide. Tellurium trioxide. So I got tellurium, I have oxide, but I've got 3 of them, so that's tri. Okay? Tellurium trioxide, and again, this is for covalent. Okay? Now let's take a look at this one. Water. Well, most people know it as water, and while the scientists don't like to use this technical term, okay, it is a fun one, especially when you want to go and pull this off on people. There is a website that talks about this. We have 2 hydrogens and an oxygen. Okay, so what would that be? Well, we know that hydrogen and oxygen, we know it's covalent. We've done this before with that. So there's 2 hydrogens, so in this case here, we're going to have to say dihydrogen. Now we have 1 oxygen, so that means it's going to be monoxide. So dihydrogen monoxide is one way to describe water, and it's a fun little one that you can pull off on people. You can talk about the dangers of dihydrogen monoxide. People waste it, people bathe in it. Every year people consume vast quantities of it. You can have a little bit of fun with that. Okay, let's go for another one here. Let's skip down. Let's look at BRCl. Okay. BRCl, so here's Br and here's Cl. There you go. Let's see. I would not pull this off on a test, but notice it's Br by itself. We don't say monobromium. We don't, okay? We can say bromium. Now, I use chloride myself, bromium chloride, but you can also use monochloride, bromium monochloride. You could also use bromium chloride. People would know what you're talking about. Here, let's look at this one, P with the Cl2. Again, let's take a look. Where is our phosphorus? That's right here. And here's our Cl. If you notice, these elements are very close to each other. That's the covalent, okay? And that's when we have to use the numbering system like we have here. So, that would be phosphorus dichloride. That would be phosphorus dichloride. Okay? Let's do one more and then we're going to call it. Okay? So here we have IF7. Now, because we have 1 iodine there, and we can check where does iodine and fluorine, okay, here's iodine right here in our little box, and here's fluorine. Again, they're pretty close to each other. So this will be a covalent, no question about it. Okay? We don't need to put mono in front of the iodine. If we say iodine, we know that there's only 1. The only time we need to put the mono is if for the second half of our compound. So in this case here we have iodine heptafluoride. Okay? So, guys, I hope this gave you some ideas here on naming covalent, compounds. Remember, it's different from ionic compounds in that in covalent compounds, you have to tell how many of the second part that you have, and if you have more than one of the first part, like dihydrogen monoxide, classic, okay? As opposed to ionic, remember, when we think about here, this would be covalent, okay? This would be covalent. How come? Because they're very close to each other. That electronegativity isn't all that large, but when we're talking about, here's sodium and we're going all the way over to chlorine, that is so ionic. It just is. It's just ionic. So the further away they are, they're ionic. When they're close like this, when they are in the hood, so to speak, that is the covalent. So that's how you know, when you look at a formula, look where the two parts come from. On the test, it wouldn't be any more complicated than what you got on this paper. Okay, guys, I hope this helped out, and goodbye, God bless you, and God does love you. John 3:16, dudes, and John 14:6.